Hello everybody, this is Carlos, and today we're going to be talking about stochastic flow models. Mainly we're going to be talking about Possions model, which the equation is Pn equals lambda t to the n power multiplied by e to the negative lambda t over n factorial. So this equation here determines the probability of certain amount of cars passing by in a certain time frame. So the Pn here stands for, I'll write out everything stands for. So Pn is probability of observed number of, it could be vehicles, people, whatever. Vehicles, time frame. So that's what Pn will give you. And here, the lambda will give you the rate of vehicles per second. So this is what lambda is. T is just time. And n is the number of cars. Alright, so this formula isn't only used to determine the amount of vehicles. We could also make the n equal to 0, and this way we could find the probability of a certain amount of time where there's no cars passing by. So here, if we make n equal to 0, therefore the equation would equal this part here. If it's 0, just go to 1. So it would equal e to the negative delta over t. The factorial of 0 would just equal 1. So all we're left with is e to the negative lambda t. And this probability will give you, here the probability will be a certain amount of time where no cars will pass by. So having this equation and this equation, we can now move on to examples. So here's an example with the left turning lane at an intersection with the 6 vehicle capacity. And the flow rate at this intersection is about 20 vehicles per minute. And 25% of this flow will turn left, which is roughly 5 vehicles per minute. So if the capacity is 6, and not always will there be 5 vehicles that will turn left, we want to know the probability of spillback, which if there would be more cars turning left. So our lambda here would be the 5 vehicles per minute, because those are the cars that will be turning left. So then we would use Possions formula, which is P equals T n times e to the negative lambda t n factorial. So the probability of spillback to occur would be P n is greater than 6. And to figure this out, we would do 1 minus the sum of the probabilities from 0 to 6. So to get the probability, we make a chart of number of n's from 0 to 6. So you get your n. 1, 2, 3, 4, 5, 0.6. Get your P of n. And at the very end, we will get the sum of all our P of n's to plug back into here to solve for the probability. So you get your n and you plug it, each value you're going to plug into your Possions formula. So for the first one, you'll get lambda, which equals 5, t for time, which is 1 minute, and your n to the 0 multiplied by e to the negative lambda, which is 5 times t, 1 minute, divided by n, which is 0, factorial. This will be 1, this will be 1, and the answer you will get for here would be 0.00674. So this is an answer for plugging in n equals 0, 674. So if you do the same for the rest, 1, 2, 3, 4, 5, 6, you should get values. So these values will be, so now that we have all the values, we could sum up all the PNs, and our value will be 0.7621, which is the sum of all the PNs. Now that we have all the sums, we could plug back in to this formula to find the probability of more than 6 cars coming into the left turning bay. So since we have the sum, we could plug back into here, equal 1 minus 0.76218, and this will give you 0.23782, which is equivalent to roughly 23.8%. So here, 23.8% of the time, there will be spillback on the left turning lane. So if we work on another example, rather than finding the probability of how many cars will pass by, we could also use the Possions model to find out the probability of when there will be no cars passing by. So here we have a highway with a flow rate of 400 vehicles per hour passing by. And we want to know how many gaps are greater than 6 seconds. So we want to know no cars, so n will equal 0. P n equals 0 will be lambda t 0 times e t n to the 0. So we know these cancel out, and we're left with a much simpler formula, which is just e to the negative lambda multiplied by t. So before plugging our lambda in, we can see that our time is in seconds. So we want to convert our flow rate, rather than vehicles per hour, we want to convert it vehicles per second. So write this up here. Lambda equals 400 vehicles per hour. We want it per second. So there are 3,600 seconds in an hour. So to cancel this out, we will write 1 hour over 3,600. So our lambda will end up equaling 0.00674. 0.011 vehicles per second. Now that our units are correct, we can plug in the numbers. So lambda 0.11 multiplied by t 6 seconds will equal 0.5134. So the number of gaps that will be greater than 6 seconds will equal our value here, 0.5134, multiplied by our original flow rate, which will take in count as vehicles per hour, 400, will equal 205.37 gaps per hour.